In this video we're going to look at another example of simplifying something using the laws of exponents. Here's our problem up here. We got x to the 1/2 times x to the 3/10 times x to the 2/5 all over x squared to the negative 1/2. Here's our laws of exponents. We're going to have to know these in order to solve this problem. There's actually one more that I want to add, which is x to the a over x to the b. How do I simplify that? It's kind of pairing along with this very first law. X to the a times x to the b is x to the a plus b. If I have x to the a over x to the b, that's x to the a minus b. You got to subtract the exponents in that situation when you're dividing. And there's a little variation that can happen with this, but generally this is a good rule just to start with, and we'll see what happens when we solve this problem. Maybe I'll talk about another way to look at it. Alright, so here we go. I have my numerator. Looking at these laws, you should be able to look at these laws and say, which one of these laws do I need to simplify my numerator? What does this pattern look like? Hopefully you've got a rule picked out before I tell you. That's one thing about math. If you can kind of stay one step ahead, that's a good sign. So x to the 1/2 times x to the 3/10 looks like this to me. X to the a times x to the b. And we can just add another, if we multiplied another thing in there, we're just going to add that exponent as well. So basically we need to add all these exponents together. I need to add all these fractions, 1/2, 3/10, and 2/5. Let's go ahead and write that out. X to the 1/2 plus 3/10 plus 2/5. I still got to figure this out, but we'll just write that down for now. We'll figure it out in a minute. In the bottom, let's look at these rules. What do you think? X to the 1/2, x squared to the negative 1/2. Well, just looking at this, I'm thinking it looks like this one right here. X squared to the negative 1/2. What do I do with those two exponents? I multiply them. So 2 times negative 1/2 is negative 1. Now I'm going to have to do something with that negative 1 here in a minute, but I'm going to go ahead and work on my numerator. I have to add all these fractions together, and I'm going to have to drum up something from the good old days, which is getting a common denominator. So 2, 10, and 5. The least common denominator would be 10, so I want to change these all to tenths. So 1/2 would be 5/10. Multiply the top and bottom by 5. The 3/10, I'm just going to keep that how it is. And then 2/5, that would be 4/10. And I'll just go ahead and write this in here, how I'm getting this. Most of you probably already know, but so this 1/2 I times by 5 over 5. And this I times by 2 over 2 to get my 4/10, and then to get my 5/10 and the 3/10 I just left the same. Now we can add these fractions together. 5/10 plus 3/10 plus 4/10. 5 plus 3 is 8 plus 4 is 12. So that gives me 12/10, which reduces to 6/5. And so now I have x to the 6/5 over x to the negative 1. Everybody tracking me there? 5 plus 3 is 8 plus 4 is 12. I could just jot this down, I guess. 12/10, and that reduces to 6/5. Alright, so now we have this. It's a lot simpler than where it started, but we're still not done yet. A couple different ways to look at this. We could look at this rule right here with the negative exponent and think about what to do with this x to the negative 1. And actually it more looks like this green rule because the negative 1's in the bottom. So I could just bring it up and change it into x to the first. Let's go ahead and do that. Let's look at it that way. And then we'll look at it the other way. So one way I could look at it is, I'm going to take this, it's a negative exponent. Negative exponent means reciprocal. So since it's already in the denominator, the reciprocal would move it to the numerator. So that would give me x to the 6/5 times x to the first. When you take the reciprocal, then you change it to a positive exponent. And that would all be over 1 because there's nothing left in the denominator. And over 1 is just nothing, so I don't have to write that. Now I have something that looks like the first rule, so I can go ahead and add these exponents. So I have to do 6/5 plus 1, and 1 is 5/5. So that gives me x to the 11/5, and that would be my answer. Alright, let's see. Let's go back. I wanted to show you another way to think of this using this bottom rule. If you have this written down, that's great, because I'm going to erase this right here. I'm going to erase this from here and do it a different way. Remember, the answer was x to the 11/5. So another way to do it, if you wanted to, we still have x to the 6/5 in the numerator and x to the -1 in the denominator. If we use this bottom rule, because this fraction certainly looks like this bottom rule, it would tell me to take a minus b. Right here, a minus b. My a is my 6/5, and my b is -1. So if I followed this rule exactly, that would give me x to the 6/5 minus -1. And minus a negative is the same as plus. So there we are, back to, the same thing we had the last time. 6/5 plus 5/5 is 11/5. And that's kind of how it works with these rules. I mean, as long as you're using the rules and using them appropriately, you can get to the answer in more than one way. Well, I think it's always a good idea to practice one on your own. So let me put a different one up here for you to try. And if I have time, I'll go through the answer on how to, I'll give you the answer for sure. If I have time, I'll go through the steps. Alright, here's your problem. X to the 1/3 squared all over x to the 2/5 times x to the 1/2. So what you should do is pause the video and try this one on your own, and then start it and see how you did. Alright, I think I have time to go through this if I kind of go through it a little fast. Not too fast. So in the numerator, I'm going to multiply these two together by this rule. X to the a to the b is x to the a times b. So I got to take 1/3 times 2, which is 2/3. Just think of this as 2 over 1 and multiply the numerators and the denominators. And then in the bottom, that looks like rule number 1 here, this top rule. So I have to add those exponents. X to the 2/5 plus 1/2. Adding fractions, I need a common denominator. I'll just go this way here. Leave that top as x to the 2/3. My common denominator is going to be tenths. 2/5 is 4/10, and 1/2 is 5/10. So I still have x to the 2/3 in my numerator. And in the denominator, 4/10 plus 5/10 is 9/10. Okay, so now we get to this rule right here, and it says to take a minus b. Now, if you look at this, what's going to happen if you do 2/3 minus 9/10 is you're going to get a negative exponent, which is fine. But if you get a negative exponent, you're just going to have to move it to the bottom anyway. So another way you can do it, let me write a little variation on this rule. Or you could do 1 over x to the b minus a. You can take b minus a, and when would you do this? You would do this if the bottom exponent is bigger than the top exponent. Quick example, real quick. We'll get back to this one. But let's say you had x squared over x to the 5th. Alright, 5 is bigger than 2. So you want to do 5 minus 2 and put it in the denominator. You see what I'm saying? 2 of these x's are going to cancel with 2 of these. If you just did it flat out using the first part of the rule, you'd get 2 minus 5, which is x to the -3, but then you just got to change it to that anyway. So find which exponent is bigger. In this case, the 9/10 is bigger, and so that's where your answer is going to go, in the denominator, because that's where the biggest exponent was. And then you take the biggest exponent minus the smaller exponent, because 9/10 is bigger than 2/3, and then you don't run into getting a negative exponent. Okay, real quick, finishing this up then. 9/10 take away 2/3. We got to get a common denominator, which is 30ths. So that gives us 1 over x to the, let's see, it'd be 27/30ths if we times the top and bottom by 3. And times the top and by 10, we get 20/30ths, which gives me my final answer of 1 over x to the 7/30ths for that one. Hope you got that one right. Hope this helped. Make sure you know those laws of exponents. These you just have to have memorized and be able to recognize them, and that's going to make these problems a lot less intimidating. And of course, on a problem like this, make sure you know how to add and subtract and multiply fractions.